Alrighty, this video is on your basic sine and cosine functions. This should be a review for Math 3, so I would say if you forgot it, then hopefully this video is helpful. This should not be stressful, and you should not, I don't know. All I'm saying is, hopefully you remember this back to Math 3. And if you had me last semester, then you had this worksheet. The only thing that we're adding is the tangent, the cotangent, the secant, and the cosecant functions in this little packet. This video is going to be longer just because we have to go through the characteristics first of the sine and cosine graphs. So our domain for basic cosine and sine graphs, well, remember that the domain is just going to be your x values. And usually they are going to be in a radian. Starting from now on, degree mode is dead. We don't know her. She's hibernating. The only thing that we know now is basically radians. Your range, of course, is your y value. The amplitude is the height of one wave from the midline. Now, the midline is also called the vertical shift, where you're going up and down. And the midline is essentially your new x-axis in terms of your points. Amplitude, the heights of one wave from the midline, is basically saying, if this is my midline, what's my distance from the maximum point and the midline? Or what's the distance from my minimum point to the midline? You'll see that they should be both the same because your amplitude is just distance. So amplitude is never negative. You might see something like -2 cosine of 3x plus 4. Don't say that this is an amplitude of -2. This is an amplitude of 2 with a reflection over the x-axis. The period is the horizontal distance of one cycle before it starts repeating. So you'll see here that I have dots right here. And then going afterwards, I'm going to start repeating. Or from here, you'll see that, oh, I have this dot. I'm repeating myself. So this is going to be a distance of 2 pi. If I start from my starting value and then I end at my ending value, this distance is 2 pi. My phase shift, just like regular equations, that's where we go left and right. This is also going to affect my reference points if I have them. Whenever we graph, we are going to identify the amplitude and the period. So whatever they are, that's going to help us graph. We're going to identify my reference points by using my period to find values for one complete cycle by using fourths. And then we are going to add any horizontal shifts if there are any. We're going to graph the midline, which is my new x-axis. And we're going to plot the points based off of it being a sine function or a cosine function. We're going to connect the 5 points with a smooth curve and graph one complete cycle. This part may or may not be true in terms of the test. You might be asked to graph 2 cycles, or might be asked to graph the whole thing from -2 pi to 2 pi. Oh, and that was number 5. Wow. And if you were to be asked to graph more than one cycle, just extend your graph left to right. Now, looking at my sine graph, I have your basic 1, 0, and negative 1, which relates back to the unit circle of 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. Since this is a sine function, which is my y values, I'm going to look at my y coordinates right here. So at 0, I'm going to be at 0. At pi over 2, I'm going to be at 1. And then at pi, I'm going to go back down to 0. At 3 pi over 2, I'm down to negative 1. And then at 2 pi, I am back at 0. So your sine function starts at the midline, goes up, goes back down to the midline, goes down low, and then comes back up. So that's your basic sine function. If I were to look at my cosine function, where it represents my x, notice how I start high because I start off at 1 whenever I have 0. And then at pi over 2, I have 0. At pi, I have negative 1. And then at 3 pi over 2, I have 0, my midline. And then at 2 pi or 0 again, I start repeating myself and I'm back at 1. So for my cosine function, I start high, then go mid, then low, then mid, then high. All right, so let's look at number 1, and let's see how can we graph this. I have sine of 2x plus 1. And to find my amplitude, that's my a value. I don't really necessarily have an a value, so my amplitude is 1. So that's my distance from my midline to the maximum minimum. My period is 2 pi over b, which represents my horizontal length before it starts repeating itself again. So this is saying 2 pi over 2 or pi. How am I getting 2? Well, my b value right here is 2. So I have a period of pi. I don't have a phase shift, so lucky for us in this problem. And then I have a vertical shift of up 1, which means that I have a midline at 1. I'm going to graph that. And then I'm going to find my quarter periods by going from 0 to pi, which represents my length of this sine function before it starts repeating itself. Like I said earlier, we are going to divide this into quarters, and I'm going to add that on here. So I'm going to get pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4, which is this thing right here. So I should have 4 sections. Oops. I'm going to start at 0, and since this is a sine function, this tells me that I'm going to start at my midline at 0. Then I'm going to go up, then down, and then down again, and then up. So this is going to represent my function right here. I'm going to cheat a little bit because I have notability. I am just going to play a game of copy and paste to get my whole thing. Isn't this cool? And there it is, sine of 2x plus 1. All right, number 2 is a little bit harder because this actually has all the transformations. So going from 1 to 2, whew, it's a jump. All right, so I have an amplitude of 3. a period of 2 pi over 2, which is just pi. I have a phase shift of right pi over 4, and then I have a vertical shift of down 1. My t right t represents my b value. My right pi over 4 represents this value. And then my down 1 is going to represent my midline. To find my reference points, I have my period of 0 to pi. And then I am going to add in my quarters, which is the same thing that I had up here, except this time, because I have a phase shift of pi over 4, I'm going to add everything by pi over 4. So this right here represents my new reference points. At pi over 4, since this is a sine function, I'm still at my midline. Then I'm going to go up to pi, or 2 pi over 4, and then down to my midline, then down to my minimum, and then back to my midline at 5 pi over 4, which is where I stop. Oh, Buddha. This is wrong. Notice how I have an amplitude of 3, so I need to make sure that my distance from my maximum and my midline is 3. That's embarrassing. 1, 2, 3. Okay, here's something better. Notice how from my midline to my maximum, or my midline to my minimum, it is a distance of 3. Okay, I'm just going to copy and paste. You can't do that, but I might just ask you to just graph one period and call it a day. So, yay. This doesn't really line up, but okay. Good enough, close enough, right? Yeah. Of course, make sure that you have arrows representing that this goes on forever and ever and ever. Okay. So I have... I'm going to do number 4. I don't want to do all these problems. We are going to factor out 2 cosine 1/2 x plus pi over 2 minus 3. And the reason why we want to factor this out is because my coefficient is not 1. So we're going to cry for 2 seconds because my coefficient is not 1. But we can make it 1 by factoring out 1/2. Now, if I factor out 1/2, that's going to leave me with pi as my phase shift. So I'm going to go left pi. My amplitude is 2, and then my period is 2 pi over 1/2, which is 4 pi, which essentially is going to take over this whole thing. I have a vertical shift of down 3. So -3, aka my midline is at -3. All right, so my period is from 0 to 4 pi. I'm going to take quarter period, so I'm just going to add a pi because 4 pi divided by 4 is just pi. And then I have a phase shift of -pi, so I'm going to subtract everything by pi. And these are going to be my reference points. I'm going to start at -pi, and since it is a cosine function, I'm going to go up. And since my amplitude is 2, I'm going to go up 2 from my midline. I'm going to go to 0. That's going to go back down to my midline. Pi is going to go down to -4. 2 pi is going to go back up to -3. Now, you'll realize that I can't do 3 pi, meaning that I can't really finish off my cosine graph. Well, plot twist, we have the other way around, where I could use -2 pi now. That's going to go down to my midline. And then I could graph. So your graph should look something like this. I'm not going to do number 5, but I am going to do number 6, because this question's asking us, given that we have 3 cosine 2 times x plus pi over 2, how can I convert this into a sine graph? Well, before I do that, I need to take care of this and figure out how can I graph this before I do anything else. Your amplitude is 3. Your period is 2 pi over 2, which is just pi. You have a phase shift of -pi over 2. And then you don't have a vertical shift, which means that your midline is still at y is equal to 0. Because my period is from 0 to pi, I am going to make quarters. And then I am going to subtract pi over 2. Ugh, this is going to be a little bit nasty. All right, once I get that, this tells me that I'm going to start at -pi over 2. And since it is a cosine function, I'm going to start high. So I'm going to go up 3. Then I'm going to go down low. Then I'm going to go to 0 and go down to -3. I'm going to go back up. And then I'm going to go back to my maximum. Once I have that, then I am just going to repeat myself. And then we're going to see how can I make this to be a sine graph. So what I'm going to do is probably delete that. And then try to copy this. To the best of my ability. And then just sketch it. Make sure that it is curvy and not sharp. So like this scene right here would not be good because it's not curvy enough. I would say it looks sharp. So just make sure that something like that. Trying my best, and once we get that, the question's asking us, how can I make this a sine graph? Well, in order for me to make it a sine graph, I need to make sure that it starts at my midline, and I go high first. So out of these points right here, notice how at pi over 4, it starts on my midline, and then it goes up. So I could rewrite this to be 3 sine of 2 x minus pi over 4. Notice how the only thing that I'm changing is my phase shift, and that's it. I have a phase shift of right pi over 4, so that's why I have a minus pi over 4 right there. Now, I can also ask you other questions, such as, how can I make this to be a negative cosine graph? Or how can I make this a negative sine graph? So just depending on what the question is asking, you want to make sure that you answer it based off of what it says. So the reason why I really like this unit is because there are a lot of different representations going on. Because instead of this equation, you could have this equation. You could have other equations based off of what the question's asking you. Like number 7 here, I told you to do 2 things. How can you make this a positive cosine graph? And how can you make it a negative sine graph? Well, I don't know. It's up to you to figure that out. Alongside with the other problems that we didn't do, like 5 and number 3.